Okay, so our previous notes, we talked about lines cut by transversals and the different angle pairs that we had. What's going to happen in these is we are now going to go specifically to parallel lines cut by a transversal. So now we're going to wind up with something else happening here. So we're going to write in these blanks when a transversal, the first blank is transversal. And again, make sure you pause and get these words in. When a transversal cuts through two parallel lines, we get several unique angle relationships. So they're going to have a certain relationship so we can actually figure out, if I give you one angle measurement, what's the other one? Or if I give you some algebra, we can set it up. So what we're going to do here is, this is where in class we need 4 colors. I probably should have warned you that first. We want to make sure we have a highlighter in 4 different colors. So please pause and go get those materials. So now we're not going to highlight the definitions again, but we'll talk about them. But what we do want to see here is the first one we're going to talk about is going to be your alternate interior angles. These are going to be on opposite sides of the transversal, and they're going to be in the road, between those two parallel lines. And what we need to focus on today's notes is that these alternate interior angles will be congruent. Okay? They will be congruent. So we're going to take a look at the picture, and we're going to go ahead and we're going to take 2 different colors because we have 2 different pairs of alternate interior angles. I want you guys to notice we have these little arrows here telling us that we have parallel lines. So with our first color, we want to make sure that we stay on the interior of the road. So this is where I always draw like a little car so I can see in the road, especially now we have parallel lines. It looks more like a street or a road. So that car's driving in the road in the interior, so we need to stay on the interior. So if I start off at this angle right here, I need to go to the opposite side opposite side of the transversal, and I need to stay interior. Remembering that we can't just do this angle right here because that would be right next to each other on a line linear pair. They're going to be connected, okay? So we've got to go over here to this angle, the other alternate angle, all right? So we have one of your alternates. We've got one on to the left of the transversal, one to the right. Now keep in mind, if your picture looks like this, it's not going to be the left and right. You'd have one angle above and one angle below. Again, you can always rotate your page if you don't like the way the picture looks. We do have our other pair of alternate interior angles. We've got this angle here. Go to the other side, and there we go. There's our other alternate interior angle. For your alternate exterior angles, they are also going to be congruent. So we're still on opposite sides of the transversal, but now we're exterior. We're out of the road. We're not getting hit by that car like we did on the interior. So if we start exterior, remember we've got 2 different exterior places. We've got up here and we've got down here. Let's go ahead and start with this angle right here. So I'm going to go to the alternate side and I'm going to stay on the exterior, but I've got to go to the other exterior. So we're actually going to cross the road, okay? But while crossing the road, we're also crossing that transversal. So we were to the left of the transversal. Now we want to go to the right, but on the other exterior portion. And then we have our other alternate exterior angles right here and right here. Okay? Why we have the colors. If you're just using pencil, you're just going to have a bunch of dots everywhere, and you're not going to know what's going on. So I want to change these colors up. Both of your alternate angles, alternate interior and exterior, will both be congruent, meaning their measurements are equal. Okay? Moving to the same side interior. So we're on the same side of the transversal now, and in the road with the car, interior. These will now be supplementary. So when we take a look, because I'm doing interior angles, I like to draw that little car so I can say make sure we stay in that road. If I start with this angle right here, interior, I need to stay on the same side of that transversal. I just move to the other interior, right there. And then we will have our other pair of same side interior on the right-hand side of this transversal, staying on that same side. Okay? Your same side exterior, we have that same side exterior. So now we're going to same side, but now we're going outside the road, outside those parallel lines. They will also be supplementary. So here, if I start again with this exterior angle, I need to go to the other exterior region, and I need to stay on the exact same side. I'm to the left of the transversal, I need to stay to the left. Or if it's like this, you're above the transversal, you need to stay above the transversal. And then we can identify our other pair of same side exterior angles in these two locations right here. The best way I can help you remember same side interior angles and same side exterior angles are going to be supplementary is those S's. Same side supplementary. Okay, same side supplementary, same side supplementary, same side supplementary. Okay, get that stuck in your head? We're good to go. You remember your same sides. If they're on the same side of transversal, they will be supplementary if they're same side interior or exterior. Now your corresponding angles, these are going to be the ones in matching positions. These are going to be congruent. The easy way I can help you out with that is C for corresponding, C for congruent. Now, as we discussed in the last lesson, we actually have 4 pairs of corresponding angles because what we're talking about is positions. So we're looking at an intersection. We have 4 different angles, so we have 4 different positions. Top left, top right, bottom left, and bottom right. So I'm going to have the same 4 matching on the bottom. This is why I mentioned having 4 colors. We've only used 2 so far. So let's go ahead and see our first corresponding angles. I'm going to start at this intersection. I'm going to go ahead and start at the top left angle. I'm going to go to my bottom intersection, and I'm going to go to the exact same position, top left of that intersection. So I'm going to go to the top left. Same corresponding matching position. Then I go back up to the top intersection. Let's go to the top right. So the top right will correspond and match the other intersection, top right, right here. Keep following that pattern. Over here, let's now go to the bottom left. So here we have the bottom left. The other intersection, I'm going to go to the exact position, bottom left, right here. Your last one is at the bottom right. It will correspond and match with the other intersection's bottom right. And there are your corresponding, 4 different corresponding angles. So what we're going to do is we're going to go ahead and look at an angle measurement. When you're given 2 parallel lines and a single transversal like you are in this picture right here, well, first we've got to make these parallel, right? Make sure that we can see these are parallel. When we're given 2 parallel lines cut by the transversal, we see here that we have 8 angles. I can give you 1 angle measurement and you can find all other 7 based on what we just talked about. We're not going to find all of them, but we're going to use these different relationships, congruent or supplementary, to help us out with the finding these angle measurements. So the first thing, make sure we are using something erasable, because we're going to be erasing things in our picture. So the first thing here, I want to make sure that I see my transversal to help me identify same side or alternate. And I like to draw my little car so I can see, vroom, vroom, the interior getting hit by that car, okay? So we're looking at angle 3, and we see that angle 3 is 80 degrees. We want to find the measurement of angle 6. So we're looking at what angle pairs angle 3 and angle 6 are. So I'm looking at, okay, my transversal. Am I on the same side of the transversal, or am I on alternate sides? I see that I am on alternate sides. 3 is to the left, 6 is to the right. And I also notice that both angles are in the road interior. So we have alternates, interior angles. And if you look back up, you find your alternate interior angles. They are congruent, meaning they are equal. They have the exact same measurement, meaning angle 6 will also be 80 degrees. When we move to the next bullet point, what we're doing is we're taking that information from angle 6 and we're bringing it down, saying, okay, well, now that we found angle 6 is 80 degrees, what I want to do is I want to go find the measurement of angle 4. So I'm going to compare angle 6 and angle 4 here. And I notice that they're both on the same side of that transversal, and they're both interior. So I have same side interior. And if we take a look at the chart above, that table above, what we highlighted, we go to our same side interior, and we saw same side supplementary, all those S's. Okay, so they are supplementary, meaning, probably something we should add in here, do with the classes. We need to remember this means we have two angles adding to equal 180 degrees. You have to remember that. Okay? So when we go back down to angle 4 and angle 6, we already know that angle 6 is 80 degrees. So in order to find the measurement at angle 4, we know they add to equal 180. So all we have to do is take the 180, subtract that 80 degrees from angle 6, find out what's left over for angle 4. We're going to find out we have 100 degrees. So we're going to transfer that down. The next bullet point, the measurement at angle 4 we know is 100 degrees. So we're going to go ahead and compare angle 4 now with angle 8 right here. So angle 4 and angle 8 I see are on the same side of that transversal, but when I'm looking at interior and exterior, I'm seeing one is interior, one is exterior. When you have one interior and one exterior, you have two options. You're either going to have corresponding or no relationship. Well, how do you know the difference? Well, your corresponding have to be in the exact same position. So check out the positions. Start at the center of that intersection. Angle 4 is on the bottom right. Start down here. Angle 8 is at the bottom right. They match. They are in the exact same positions, so we have corresponding angles. Again, make sure you're pausing so you get all this stuff written in. So we look back at our chart up here, and we see corresponding C, congruent C. So these two angles will be congruent, meaning if angle 4 is 100 degrees, angle 8 is also 108 degrees. Bringing it back down to our next bullet point, angle 8 is 100 degrees. We already have that from here. So we're going to go back to our picture. And now we want to compare angle 8 to angle 1. So we're going to take angle 8 and angle 1 and check these guys out and see what's going on. Angle 8 and angle 1, I notice that they are on alternate sides of that transversal. One's to the left, one's to the right. I also see that they are exterior. So we're going to have your alternate exterior angles. And again, going back up, we look at alternate exterior angles, we see, that's why I just wanted to highlight the word congruent or supplementary. Alternate exterior are congruent, meaning they are equal. They have the exact same measurement. So if angle 8 is 100 degrees, angle 1 is also 100 degrees. Down to the last bullet point, we're seeing that, okay, well, we already know 100 degrees, angle 1 is 100 degrees. We're now going to compare angle 1 with angle 7. So angle 1 and angle 7 here. I'm noticing that angle 1 and angle 7 are both to the left of that transversal, meaning they're same side. And I'm noticing they're both exterior. So we have same side exterior. And we look back at our chart, same side supplementary. So our same side exterior will be supplementary, meaning they add to equal 180 degrees. So again, we can just go to the side and say, okay, that 180, we're going to subtract whatever angle 1 is, that 100, and we're going to wind up with 80 degrees. So angle 7 will be 80 degrees. All right? So we're going to take this and we're going to kick it up a notch. On the other page, we are going to start looking at we're looking at algebra, setting it up with algebra. So here, one thing I always suggest my students do is highlight what they want you to solve for. If it's at X, or do you need to substitute it back in? We're just going to go ahead and nail all these out right now. All three of these are going to be solving for X, no substituting back in. Okay, so go ahead and get those three highlighted. And then I like to highlight my transversal so it pops out at me so I know same side or alternate. And then I'm going to draw my really awesome car that I do, right? A really super duper realistic car, vroom vroom. So again, we're going to be doing some erasing. Okay, so make sure we're using something erasable. The first problem, I'm going to be comparing angle 1 and angle 5. So I'm going to come over here to angle 1 and angle 5. And I need to check these guys out, find out, okay, first, what type of angles or what angle pair do I have? So then I could say, what relationship do they have? Type of angles is the name. Corresponding, alternate, those. Your relationship is congruent or supplementary. So I'm noticing that angle 1 and angle 5, 1 is to the left, 5 is to the right. So I'm on alternate sides of this transversal, and I'm noticing that we are out of the road where that car is, so we are exterior. So we have alternate exterior angles. So here we can write alternate exterior angles. Now I'm going to write a little bit different stuff. I'm going to write a little bit extra here because I feel that, more places we have this information, the better off we'll be. Up here underneath, we're going to write AEA. That stands for alternate exterior angles. So since we have alternate exterior angles, we can include therefore. That's what these 3 dots means. A reminder for anybody who's watched my videos. The 3 dots just mean therefore, so we can conclude our alternate exterior angles, as we looked on our chart over here, alternate exterior angles are congruent. So we can say they are congruent, just with our symbols rather than writing the words out. And when 2 angles are congruent, their measurements are equal. That's a big thing I have my students say, is I have to hear equal, not same. This is why. Because that way we know that we need to set these angles equal to each other. So measurement at angle 1 will be equal to the measurement of angle 5. So now we will go ahead and substitute in for our information. The measurement at angle 1 was 120. We're going to set that equal to the measurement at angle 5 was 20x. I noticed my students, it was kind of throwing them off a little bit. All we have to do to solve for x, so we have 20x is equal to 120. So we got to get rid of that 20 here. All we're doing is dividing by 20 on both sides. The 20s disappear on the left, the right, and x is going to equal 6. And that's all they wanted, was just solving for x. Okay? So we're going to go get those erased so we can look at the next 2 angles. On number 2, we want to compare angle 7, and we want to compare angle 6. So I'm going to go up here, I'm going to find angle 7, and I'm going to find angle 6. We take a look at these. We are on the same side of that transversal, and we are both interior getting hit by that car. We're in the road, in the interior of the parallel lines. So we have same side, interior. Here we can write down same side, interior. Abbreviate that interior. And we'll do like we did with number 1. SSIA. Same side interior angles. Therefore, when we take a look at that chart, our same side interior angles are going to be supplementary, meaning they're going to add to equal 180 degrees. So we'll put therefore supplementary. So again, they're going to add to equal 180 degrees. So we have the measurement at angle 7 plus the measurement at angle 6, all equal to that magic number 180 degrees. We're going to substitute in the measurement at angle 7 we saw was 4x plus 50. So we'll put in 4x plus 50. We're going to add the measurement at angle 6, which we see as 4x plus 10. Don't forget that equals 180. I've seen some students drop that off and they think, well, now you don't even have an equal sign. Okay, don't forget that equals 180. Now when we start solving, we need to notice that horrible mess that we have on the left-hand side, that equal sign. We have way too many terms over here. You cannot start moving things around from one side of the equal sign to the other until you clean this up. You have to combine your like terms. So here we're going to look at our variables. We have a positive 4x and a positive 4x, leaving us with, you got it, 8x. And then I have this positive 50, my constants, and this positive 10. You guys know what that is. Go ahead and write that down. Total confidence in you. If you're not my student, you got it. We've got a plus 60. Don't forget your equals 180. Okay, I've had some students who forget the equal sign and then they don't know what to do because there's no equal sign. All right, we have our 2 steps left of solving for x. We're going to get rid of that 60 by subtracting 60 from both sides. Bring down that 8x, and yes, I'm going fast on this because if we need help, we need to get it from a teacher, a friend, a video, something, solving for x. Last, divide by 8. We're left with, we're not dividing by 8x, we're only dividing by 8 because we still need that x. So we're going to bring that x down, and we're going to find out that 120 divided by 8 is 15. Okay? The last problem here, number 3, we're going to compare angle 2 and angle 8. So let's go back up here and compare angle 2 and angle 8. So we have angle 2 and angle 8. Now, very, very quickly, let me explain what's happening here. Some of you already know what kind of angles you have. We need to understand the difference between the 2 angle pairs we learned in 2B, your vertical angles and your linear pair, and these 5 new angles. These 5 new angles have to have the lines and the transversal, meaning you're going to use both intersections. You're going to have an angle from each intersection. If you find yourself in this position where you're not using an intersection at all, notice that we're not using angles 3, 4, 5, or 6. We're not using that. That means we either have a linear pair or we have vertical angles. So you need to look at what happens is these angles are going to connect somehow, vertical and linear. They're going to touch. They're going to be by each other. So here we need to look at, are we right next to each other, forming a line, or do we jump across the vertex? If it's a line sitting right next to each other, adjacent, we have a linear pair. If we jump across the vertex, vertical. So here we have a pair of vertical angles. So down here, we'll go ahead and write in. I'm just going to put vert and then the angle sign. And we take a look at what we've learned with vertical angles. We have vertical angles, therefore, your vertical angles are, you got it, congruent. Okay? So when 2 angles are congruent, their measurements are equal. Set them equal to each other. Measurement of angle 2 is equal to the measurement of angle 8. We'll go ahead and substitute our algebra in now. The measurement of angle 2 we found was 3x plus 20. The measurement of angle 8 was that 4x plus 10. And I notice on the left and the right, there's nothing to clean up. I've got a variable and a constant on the left. I've got a variable and a constant on the right. Nothing to combine. So now we're going to start moving things to the left and right. We need to get our variables to one side, our constants to the other. I always suggest move the smaller variable first, the variable with the smaller coefficient first. So I'm going to get rid of this 3x by subtracting it. Bring down that 20 constant that's still there. I had 4 x's. I got rid of 3 of them. How many do I have left? 1 single x. Don't forget to bring down that constant of plus 10. So now our variables got moved to one side. Let's get our constant to the other side. So we need to move this 10. We need to move it by subtracting to zero it out. Cancel. And then we're just left with x on the right. When we subtract 20 minus 10, we're going to get, you got it, 10. Okay? So hopefully we've got this, and hopefully with this practice we also understand the angle pairs and how to name them a little bit better.